All right, problem 5-8. Graph y equals 1/2 x minus 3 and its inverse function on the same set of axes. Letter A, what is the equation of the inverse function? Well, let's go ahead here and figure out what our inverse function is going to be. If we wanted to graph y equals 1/2 x minus 3, let's start out here. Let's just go ahead and write that down. Y equals 1/2 x minus 3. Now, depending on what you did in your class today, there are different ways to come up with the inverse function. But before we do it, let's graph this one. And as I do it, I am going to go ahead and record the points on a table. So those would be my inputs and my outputs. Now I know already here, if I'm going to graph this, this is just a linear function. I have my y-intercept over here. This would be at -3. So I've got, right now I know the point 0, -3. And let's use our slope to come up with some more points. So we go up 1, we go over 2. We go up 1, we go over 2. We go up 1, we go over 2. And we can go the other direction as well. Down 1, left 2, down 1, left 2, and so on. Now we've got a line there, and I'm going to have to get out my line tool because I struggle with drawing straight lines on here. So we're going to cheat a bit. So let's take it here, and right there we have our line. So let's look at some of the other points that we had on there. So we had 0, -3, we've got 2, -2. We go over here, we've got 4, -1. And let's include one more on there. Let's go, that would be the point 6, 0. And I'm sure you probably see the pattern that's going on here. So I know I also will have -2, and I would have been at -4. I'd be at -4. I would have been at -5 for my y, and let's just do one more. -6. We would have been at -6. Let's double check it. -6, -6. So now in class you probably talked about how to find the inverse function, and one way that we looked at it was we noticed that our inputs and outputs were ending up switching places. We were actually switching our x's and our y's. So if we want to just graph our inverse function, we can take it here, and now let's switch it and put our outputs are our new inputs. So we're more or less just taking this list of points, okay, or these coordinates, and these are now becoming our input values. So they become our x's here. And what was our input is now our output. So we've literally switched our x's and our y's there. So we had -6, we had -4, we had -2, so it was increasing by 2 each time there. Then we had 2, we have 4, and we have 6. So we're going to graph the inverse on here now, and I'll graph this one with red points. So I'd be at -6, -6, so that ends up being on the same location as the -6, -6 on our other graph. And then we've got -5, -4. So back 5, down 1, 2, 3, 4. We've got -4, -2. We've got -3, 0. We've got -2, 2. And you can kind of see the pattern that's going on here. And let's just continue it just past it there. So you kind of see this is our inverse function, what it's going to look like. I'm going to go ahead here and do my line here. We'll do this one in red. Oh, that's a big red there, but maybe we'll be able to adjust it here. Let's just make that a little bit thinner. That's better. All right, sorry about that. Technical difficulty, we're good to go. So now we see here that we have our function, we have our inverse function. They're both graphed on here. Now the question is, what is the equation of the inverse function? A couple ways you could do it. You could take 2 points here and come up with the uh, what the linear equation would be. Find your slope, your y-intercept there. Another way that you talked about doing it in class was by undoing what we have here. If we list out our steps that we have for our original function here, we're taking x and we're multiplying it by 1/2, which is the same thing as dividing it by 2, right? So we could say we're dividing by 2, and then we were subtracting 3. Well, with our inverse, we are going to do pretty much the opposite. We're going to go in reverse order. So to undo what we would have done there, if we started out with just an x, the first thing we would do there, instead of subtracting 3, we would add 3. And then instead of dividing by 2 or multiplying times 1/2, we would multiply by 2, which is the same as dividing by the 1/2 there. So if we had an x, let's think about that. If I added 3, I would say x plus 3. And if I took that then and I multiplied it by 2, I'd want to say I was multiplying that whole thing by 2. And I end up with the equation for my inverse function. So this is our red function is the inverse of our black function there. Now if we distribute our 2 through, we'd have y equals 2x plus 6, and you'll see here this is our y-intercept at plus 6, and our slope is rising 2 and running 1, so that makes sense there. So what is the equation of the inverse function? We have y equals 2 times the quantity of x plus 3, or if you simplified it out, you could have probably come up with y equals 2x plus 6. Either way works there. Now, it says, does this graph, including both lines, have a line of symmetry? If so, what is the equation of the line of symmetry? Well, if we look here, they're both going in these different directions here. This one's rising 2 and running 1. This one is rising 1 and running 2 here. They both share this point, and if you look here, we kind of have they're kind of got a line of symmetry that would run right through here. So if we can figure out what this line is, that might help us to come up with the equation. So this point we know is the point -6, -6. And these points are all equidistant from the origin as well. So if you thought about it, it goes through -6, -6, and 0, 0. Well, what do you notice here? This is an x, this is a y, this is an x, this is a y. What would the equation of this line be that goes right through there? Actually, let's do this. Let's say we'll make this green. If we're looking for our line of symmetry, it would kind of run right through there. So the equation of that line, well, the y-intercept is 0, and we're rising 1, running 1. So our equation for our line of symmetry would end up being y is equal to x. That is the line of symmetry that we have for these two inverse functions. Now we're going to be talking about different ways to come up with the equations and things as we move forward in the next couple sections. So right now, though, just remember our x's and y's, our inputs and outputs, flip-flop here when we have inverse functions. What was our input here becomes our output in our other function. and vice versa. Our outputs become our inputs. What that does, though, is that creates a line of symmetry here. That line y is equal to x is the line of symmetry. So this is problem 5-8. Hopefully this helped you out a little bit. Remember, this is just the introduction to inverse functions as we move forward through chapter 5. This is Mr. Boyd. Hope this helped you out a little bit. If not, make sure you ask your teacher. Get some help. All right. Have a good one.